Since ethanol blended fuel became prevalent in the marketplace, there have been a lot of misconceptions created by competitors of STA-BIL. Today we're going to show you one of those and why it's a myth. A common tabletop demo or myth that you're going to see is they'll add 50 milliliters of gasoline to a jar. They'll then add an eyedropper, or about 1 milliliter of water, to the gasoline. You can see that phase separation occurs. They'll then add about 20 milliliters, but I'm going to measure this out. $20 milliliters of additive. And I'll agitate it. And you can see that their product has absorbed all the water. Something that makes Gold Eagle different than a lot of our competition is that we have in-house quality control and research and development. One of our chemists, Dr. Chris Cabana, is going to run us through this demonstration and why it's a myth.
Hello, my name is Chris Cabana. I'm the chemist here at Gold Eagle. I'm going to take the numbers from the demo that Matt just showed you and extrapolate them and show you what the numbers mean in a real life situation. In the demo, what you saw was 50 milliliters of E10 gasoline, and added to that was 20 milliliters roughly of additive with a small amount of water, roughly 1 milliliter. If you extrapolate that out to the size of a lawnmower tank or the size of a car or boat gas tank, that gets to 1 gallon or 20 gallons respectively. If you extrapolate the amount of additive that is added in these demos, that gives you 25.5 ounces of additive or 4 gallons of additive in the gas tank of a car. If you're looking at that from a cost perspective, you're looking at, depending on the size of the bottle of the additive, 128 bottles of the additive to deal with the water phase separation, or roughly $600 of product that you have to buy in order to treat your fuel based on the demos that you're seeing. Now what I'm going to show you is the same demo, but with an accepted industry standard treat rate. So what I'm going to show you now is just what you saw in the demo earlier, is 1 milliliter of water in 50 milliliters of gasoline. So I'm going to exactly measure that out using a pipette of water. And then place that in the 50 milliliters of gasoline to show you phase separation. And it does indeed phase separate with 1 milliliter in 50 milliliters of gasoline. Now what I'm going to do is try to put as little as possible water to show you that phase separation occurs with a very small volume of water. And the amount that I'm really going to put in here is a very tiny amount. It's about a fraction of a tenth of a milliliter. So we're talking microliters here. So as you can see in both of these here, phase separation with 1 milliliter of water and phase separation with a tiny amount of water. This is probably about a quarter, nope, this is probably about 1/8 of a milliliter of water in 50 mils of fuel. And you can see that it's obviously phase separated. Now what I'm going to do is apply an additive based on the industry standard treat rate. Extrapolating it down to 50 milliliters, we're putting about 0.04 microliters, 0.04 milliliters into 50 mils of fuel. That really is a small amount. And I'm going to do the same thing for the other one. swirl to get them mixed properly. And as you can see in both cases, 1 milliliter of water still phase separated. And in the other example, 1/8 of a milliliter of water is still phase separated.
All right, thanks Chris for running us through it in a little more detail. The overall point of this is that tabletop demos, while they show well and they're very convincing, are typically pretty deceptive in the amount of quantity of chemical that they're using. The best way to deal with water in your fuel system is by keeping it out in the first place. And the only way you're going to do that is by keeping your tank full. There is no chemical in a reasonable quantity that's going to recombine water, ethanol, and gasoline. For more information on ethanol blended fuels and STA-BIL, visit goldeagle.com.